This is one of a series of videos on Nebraska's system of classifying and applying standards to its highways, roads, and streets. This video addresses design standards and requirements for resurfacing, restoration, and rehabilitation, commonly known as 3R. First, some terminology and acronyms. NBCS is the Nebraska Board of Public Roads, Classifications, and Standards. It may also be called the Board of Public Roads or just the Board. NDOT is the Nebraska Department of Transportation. Standards refers to the NBCS standards including design, construction, maintenance, and relaxation of standards. MDS refers to the minimum design standards, which address only the design aspect of a work or project. Standards are often termed minimum, but realize there are maximums for super elevation and grade, and ranges for cross slopes. When we say minimum, sometimes it refers to all of those. NEB-REV-STAT refers to the Nebraska Revised Statutes. NAC is the Nebraska Administrative Code. It may be referred to as the rule or the regulation. The word highway in Nebraska law also refers to roads and streets. Highway means the entire width between the boundary limits of any street, road, avenue, boulevard, or way which is publicly maintained when any part is open to the use of the public for purposes of vehicular travel. 3R is short for Resurfacing, Restoration, and Rehabilitation. For more details, see the video dedicated to 3R. FC is Functional Classification. CFR is the Code of Federal Regulations. AASHTO is the acronym for the American Association of State Highway Transportation Officials. ACET is Asphaltic Concrete Equivalent Thickness. This video provides more details on the minimum design standards, specifically for county roads and municipal streets, pages 35 through 86. The state highway standards, pages 5 through 34, are not covered in this video. Nebraska's design standards for county roads and municipal streets did not have 3R design standards until the 2016 standards became effective in May of 2016. A 3R scope of work is work beyond maintenance, but less than a full reconstruction scope of work. 3R is defined on pages 37 and 38 of the design standards. The purpose of 3R is to preserve the transportation asset and extend its life. A key component in the 3R process to be discussed later in this video is safety-conscious design. In this video, 3R will be compared and contrasted with maintenance and reconstruction scopes of work. Reconstruction is defined on page 37 of the design standards. Maintenance is defined in Title 428 NAC, Chapter 2, Section 3, pages 88 through 91. Thinking of the life cycle of a vehicle, after its purchase, there is routine maintenance that is necessary, such as changing the oil and filter. These are done relatively quickly and are low cost. Then there are those occasions that hit your pocketbook more, things like new tires or replacing a serpentine belt. These are more extensive and expensive. As those types of expenses come with more frequency, you decide it's not worth it to put more money into the vehicle, and, being smart with your money, trade it in for a new or newer vehicle. A big hit on the pocketbook. And the cycle starts all over again. It is similar for the life cycle of a road or street. After building it, there is routine maintenance, such as crack sealing, patching, and thin resurfacing. This is quick, low-cost work done possibly by city or county crews. Occasionally, there's a need to upgrade some guardrail, add an auxiliary lane, widen the shoulders, or do a thick resurfacing. These are 3R scopes of work. They are larger projects, costing more, and likely done by contractors. After so many years of patching and resurfacing, there is eventually a need to rebuild a road or street from the bottom up, replacing the base and the surfacing, or replacing a bridge or culvert. This is a reconstructed scope of work, typically the most expensive. The cycle then starts over. Choosing the right scope of work for the road or street over the years is being smart with public money. 3R standards allow more flexibility to make good choices without having to come to the Board of Public Roads for a relaxation of standards. This screen shows generally how 3R work fits with respect to scope of work and costs relative to maintenance work and new and reconstructed work. It is only a pictorial and not based on actual statistics or numbers. This video will summarize the boundaries between 3R work and maintenance work and 3R work and new and reconstructed work. As you study the design standards, you will see words such as minor, major, extensive, and selected locations that provide design flexibility and at the same time are gray areas in the standards. Minimum maintenance standards were addressed in a previous video in this series of classification and standards videos. Minimum maintenance standards are covered in Section 3 of Chapter 2. See pages 88 through 91 for the definition and limits of maintenance and a listing of physical maintenance activities. There are 4 ways the design standards distinguish a 3R scope of work from the other types of work: the base, the pavement strategy, bridges, and unpaved roads. The following screens discuss each of these, except bridges and structures, which are addressed in a separate video. Typically, maintenance is defined and reconstruction is defined, so 3R usually ends up being whatever scope is in between. That is a simplification, but it generally holds true. The base of a road or street is defined on page 42 as all layers directly or sequentially underneath the roadway surface, including layers such as a foundation course and subgrade. For the base of a road or street, the design standards establish boundaries between 3R work and maintenance work, and between 3R work and new and reconstructed work. Minimum maintenance standards on page 88 allow replacement of unsuitable base materials in patching operations, but on the bottom of page 89, anything extensive or costly would be considered a 3R scope of work or possibly a reconstructed scope of work. Replacement of the entire base or construction of an entire new base is considered a reconstructed scope of work according to the definition of reconstruction on page 39. The intent of the 2016 design standards for the purpose of establishing the boundary between 3R and reconstructed types of work is that the base being referred to does not include the base under the shoulders. For example, if the scope of work is only to reconstruct the shoulders, including replacement of the base underneath the shoulders, the Board of Public Roads does not require reconstruction of the entire road or street to new and reconstructed standards. A 3R scope of work is anything between maintenance and reconstructed. See page 39. If the surfacing is removed down to its base, but the base is not removed, replaced, or strengthened, it is considered a 3R scope of work and minimum 3R standards apply. Minor base repairs are allowed. Recycling strategies which incorporate the road structure into the base are allowed. For unpaved roads, standards allow replacement of the base at selected safety improvement locations. This will be addressed in more detail momentarily. For pavement rehabilitation strategies, the design standards establish boundaries between 3R work and maintenance work, and between 3R work and new and reconstructed work. Minimum maintenance standards on page 88 allow patching, repairing, surface treating, joint filling, and mud jacking on bituminous and concrete surfaces, and resurfacing. But on the bottom of page 89, anything extensive or costly would be considered a 3R scope of work or possibly a reconstructed scope of work. Furthermore, page 39 of the design standards limits maintenance resurfacing to a depth of 2 inches or less equivalent structure of any pavement material. Equivalent structure, or asphaltic concrete equivalent thickness, ACET, will be explained momentarily. Page 40 indicates that placement of more than 6 inches of ACET of bituminous materials or 6 inches nominal structure depth of Portland cement concrete materials requires the application of new and reconstructed standards to the work or project. With respect to pavement rehabilitation, anything in between maintenance and new and reconstructed requires the application of minimum 3R standards. This screen summarizes the thresholds for 3R standards with respect to pavement rehabilitation thickness or depth. Whenever the term overlay is used, it means an overlay over existing paved surfaces. The application of hard surfacing on an existing unpaved road is a new and reconstructed scope of work. See page 37 of the design standards. To understand asphaltic concrete equivalent thickness, or ACET, let's start with the fact that one of the purposes of many pavement rehabilitation strategies is to improve the load carrying capacity, that is, the structural strength of the road or street. For bituminous materials, which includes asphalt and recycling strategies, structural strength depends on soil support, traffic loads, service life, and the effects of the environment. For bituminous materials, different strategies can result in different levels of structural strength. Asphaltic concrete equivalent thickness, ACET, is a number that provides a way of determining and directly comparing the different levels of structural strength for those different strategies. It is based on structural number values attributed to the factors listed on the screen. This screen provides an example of asphaltic concrete equivalent thickness. Application of 2 inches of hot mix asphalt overlay would be considered a maintenance scope of work. By itself, it would not require 3R standards or new and reconstructed standards to be applied. Assume that 4 inches of recycled bituminous material has the strength equivalent to 1 inch of hot mix asphalt. It is a common ratio. Would 2 inches of recycle combined with 1.5 inches of hot mix asphalt for a total of 3.5 inches be a maintenance scope of work or a 3R scope of work? First, figure the equivalent strength of 2 inches of recycle. The assumed ratio is 1 inch of hot mix asphalt to 4 inches of recycled bituminous material, or 1 to 4. 2 inches of recycle is multiplied by the 1 to 4 ratio of hot mix asphalt to recycle. 2 times 1/4 equals 1/2 inch of equivalent structural thickness. Add that 1/2 inch to the 1.5 inch of new hot mix asphalt, and the total ACET is 2 inches of thickness. The strategy in this hypothetical example would be considered a maintenance strategy because it is 2 inches of ACET. See page 39 of the standards. The only way 3R standards would be applied to the project is if other scope of work included would be considered a 3R scope. This screen will show various hypothetical pavement strategies and the standards that would apply to each. The first panel shows 2 maintenance pavement rehabilitation strategies, a 2-inch hot mix asphalt thin overlay, and a 3.5 inch strategy that the previous screen explained has a 2-inch ACET. The second panel shows 3 strategies that would require 3R design standards for the work or project: a 2.5 inch hot mix asphalt overlay, a 6-inch hot mix asphalt, and a 6-inch Portland cement concrete depth over existing asphalt. The third panel shows 3 new and reconstructed strategies: a 6.5 inch hot mix asphalt over existing asphalt, a 7-inch hot mix asphalt over prepared subgrade, and an 8-inch doweled Portland cement concrete depth over prepared subgrade. For unpaved roads, the design standards establish boundaries between 3R work and maintenance work, and between 3R work and new and reconstructed work. Minimum maintenance standards on page 88 allow scarifying, reshaping, restoring material losses, and applying a dust palliative. But on the bottom of page 89, anything extensive or costly would be considered a 3R scope of work or possibly a reconstructed scope of work. A reconstructed scope of work for unpaved roads is defined by replacement of the entire existing base as previously discussed. Page 40 of the design standards defines situations for unpaved roads that would allow the application of 3R standards: adding, modifying, or upgrading guardrail, and minor adjustments to vertical alignment and/or horizontal alignment. Regarding minor alignment adjustments being allowable, the board is encouraging such adjustments by not requiring the entire work or project to be built to new and reconstructed standards. This screen lists several examples of 3R scopes of work. Page 38 of the design standards show 3R work scope examples. Bridge widening is a 3R scope of work, see page 38, but lengthening a bridge or non-buried structure is a new and reconstructed scope of work, see page 37. Paving an existing unpaved road is new and reconstructed work, see page 37. Replacement of a culvert, even if it is in kind, is a new and reconstructed scope of work, see page 37. This screen and the following screens show some scopes of work that would require the application of 3R standards or higher. Resurfacing up to and including 6 inches is allowed under 3R standards, extending the lifespan of the road or street, as long as the base is not removed, reconstructed, or strengthened. Minor base repairs are allowed under a 3R scope of work. Adding an auxiliary lane is a 3R scope of work. Restriping an existing road or street to do that may require a relaxation of standards for lane width. Lanes and shoulders are allowed to be widened with 3R design standards, unless something else drives the work or project to new and reconstructed standards. Minor alterations of grades and curves, vertical and horizontal, are allowed under 3R standards, unless something else drives the work or project to new and reconstructed standards. This is the before photo of Lincoln's South 56th Street project. This is the after photo of Lincoln's South 56th Street project. It was constructed prior to the effective date of the 2016 standards and needed a relaxation of standards in order to construct the project. 2016 standards would have allowed this to be a 3R project without a relaxation of standards. Bridge redecking, widening, and rail or guardrail modifications or upgrades are defined as 3R scopes of work. Stiffeners and girder bracing can be added under 3R. The bridge must meet 3R minimum bridge width and the original design loading. And it could remain load posted if the ADT is fewer than 400 vehicles per day. If guardrail is upgraded, that segment of roadway must meet 3R standards. We have discussed that a 3R scope of work is between maintenance work and new and reconstructed work. Page 38 of the design standards lists construction of curb ramps, sidewalks, and trails as items that by themselves do not require the application of 3R standards or new and reconstructed standards. Curb ramps are commonly built as part of 3R or new and reconstructed projects, so good coordination and planning are important. If only curb ramp work is done under the 2016 standards, it is essentially considered maintenance work. Turn to any of the tables from pages 55 through 78. Look in the right column, which has values for 3R criteria. Notice the word existing is used often. It is not in the definitions part of the standards, which are on pages 37 through 46. Note 6 on page 47 refers to and defines existing as existing design features. The NBCS would like to further clarify this. What this refers to are the previous design plans for the road or street. The term existing, therefore, is not necessarily whatever is out there. The term existing does not include a feature on a road or street that was not preserved or maintained to the original or as constructed condition. A tree that is allowed to grow in the horizontal clear zone or a utility pole that was allowed to be added to the horizontal clear zone is not considered existing. It is not grandfathered in by Note 6. There may be legal immunity for features on previous design plans and may be no legal immunity for poor maintenance and upkeep. The first 12 standards tables for county roads and municipal streets provide values for 5 criteria: posted design speed, lane width, shoulder width, clear bridge width, and structural capacity. All other values are listed as existing. Eight's criteria, the 4th through the 11th on this screen shown in black, are those that have existing as a value for 3R standards. Earlier in this video, the term existing was discussed in connection with Note 6 and 3R standard values. Note 6 is actually a broader note dealing with the subject of safety-conscious design. Safety-conscious design is defined on page 41 of the design standards. It goes hand in hand with 3R design work, requiring cost-effective analyses and potentially requiring safety improvements to be added to the scope of 3R works or projects. Cost-effective analysis is also defined on page 41 of the standards. A review of crash history is part of a cost-effective analysis. Highway designers must deliberately seek opportunities specific to each project and apply sound safety and traffic engineering principles. Designers of 3R projects work with existing roads and streets whose design and operational characteristics can be observed and measured. Yet not all counties and municipalities take advantage of these favorable circumstances. Greater attention to safety, along with greater documentation of the design process, improves design decisions. What might a safety-conscious design process consist of? Assessing current conditions. At the beginning of a 3R project design, highway designers should assess existing physical and operational conditions affecting safety by using crash data, site inspections, and measurement of existing design and traffic characteristics. Determining project scope will be covered in more detail on the next screen. Documenting the design process. Before developing construction plans and specifications, designers should consider preparing a safety and design report that covers existing design and operational characteristics, crash history, applicable design standards, identified safety problems and related design options, rationale for any proposed relaxation of standards, and the recommended design. Reviewing the design. Ideally, traffic and safety engineers should review safety and design reports as well as proposed 3R designs before final approval. Determining project scope. In addition to surface repairs and geometric improvements, designers of 3R projects should consider, and where appropriate, incorporate other intersection, roadside, and traffic control improvements that may enhance safety. Such improvements should be routinely considered by designers and should include improvements at intersections and driveway entrances to increase sight distance and reduce vehicle conflicts, replacement or rehabilitation of obsolete bridge rails and guardrails, removal of roadside obstacles and unnecessary guardrails, slope flattening, ditch relocation and regrading, and new or improved signing, pavement markings, and other traffic control devices. These improvements can provide significant reductions in the frequency and severity of crashes. The safety benefits of these improvements, coupled with their low costs, are such that they can be highly effective on 3R projects. Some designers may conceive their missions too narrowly, for example, concentrating on pavement repairs or confining the safety review to a few key highway features. Cost-effective analyses are an integral part of the 3R design process. The definition is on page 41 of the design standards. The purpose is to determine if a safety improvement should be added to the scope of work. It involves a review of crash history in and possibly near the work or project. For some situations, a benefit-cost analysis is required to evaluate the need and justification for a safety improvement. As part of a cost-effective analysis, the significance of crashes is evaluated, considering the number of crashes and their severity, and the relevance of crashes to design criteria. For example, a county determined that a significant number of crashes, 3, within the past 5 years occurred on a vertical crest curve with poor sight distance. 1 was fatal and 2 were serious injury type crashes. The county judged their severity as significant, and that the crashes were relevant to vertical alignment, the crest K value. The county proposed a safety improvement and estimated the benefit-cost ratio of that improvement to see if it should be included in the 3R project's scope of work. The relevance of crashes to the 13 design criteria must be reviewed as part of a cost-effective analysis. The duration, or how many years, of crash history depends on the principles of statistics. The minimum design standards are silent on the number of years to use for crash history evaluations. Some segments, such as a heavily traveled city street, may yield significant statistics by doing a 2-year study. Typical rural area crash studies are at least 3 years duration, although there may be locations when more than 3 years may be needed. Low-volume roads likely need a longer duration, such as 5 to 10 years, to collect statistically significant information. A cost-effective analysis should be documented and placed in the project file. Do not send it to the Board of Public Roads, unless, of course, it is part of a relaxation of standards request. In a nutshell, for a cost-effective analysis, if there is no crash history, you document that and you are done. If there is a significant crash history related to a design criterion, do a benefit cost analysis to evaluate safety improvement options. A previous video in this series covered notes 6, 12, and 13. To summarize, with respect to cost-effective analyses, Note 6 indicates that a cost-effective analysis is only required for roads and streets if there is a significant relevant crash history with a traffic volume of 750 vehicles per day and more when reviewing horizontal curves, and a traffic volume of 1,500 vehicles per day and more when reviewing vertical curves, or K values. The design standards do not require a particular methodology for a cost-effective analysis. This and the following screens show an example of a process for figuring costs and benefits. The example assumes that crash history has been reviewed, and it has been determined that there is a significant crash history related to a design criterion. The Board of Public Roads does not endorse this or any other particular process. The first 2 steps are determining the traffic volume, which may already be known but can be counted and calculated if needed, and figuring the number of vehicles per year. The cost of crashes to society each year are then figured in terms of dollars per crash expected to be mitigated, that is, prevented, by the proposed safety improvement. To figure these costs, the Nebraska DOT uses crash type instead of injury type. The Nebraska DOT Traffic Highway Safety Office can provide guidance if needed. The mitigated crash rate is then calculated in Step 5, followed by the anticipated savings that result from the proposed safety improvement in terms of dollars in Step 6. Finally, in Step 7, the estimated safety improvement savings for society are compared to the cost of installing or constructing the proposed safety improvement in terms of a benefit-cost ratio. If the benefit-cost ratio is greater than 1, that is, the estimated societal benefits of the proposed safety improvement are greater than the cost of installing or constructing that proposed safety improvement, Note 6 requires that the safety improvement be included in the scope of the work or project. If benefits of the safety improvement are greater than the cost of installing or constructing it, and it would be a special hardship to install or construct it, the county or municipality is required to request a relaxation of standards. The Nebraska DOT's Highway Safety Office is available for guidance for counties and municipalities. The general public must contact the Nebraska DOT's Communication Division. Crash history data may be confidential under federal and state law. The federal government has a strong law in place. There is no analogous state statute. Nebraska does have a Public Records Act. In any case, when reporting crash data in public forums, you may want to confine it to rates, types, clusters, and trends, and stay away from reporting private information. If you have questions about confidentiality of crash history information, contact your city attorney or county attorney as appropriate. To summarize why design standards include criteria and values for 3R work: 3R strategies: preserve and improve existing roadway, bridge, and roadside features, extend the life of the facility, and have the potential for improving the safety of the road or street. Life cycle costs can be reduced, and there should be fewer relaxation of standards requests. 3R standards and strategies result in an efficient use of public money. 3R is considered an interim strategy with the idea that eventually each public road and street will be brought up to new and reconstructed standards. Segments of a work or project could have different work scopes. The hypothetical project on this screen, starting at the bottom, shows a maintenance overlay. At the top is a mill and overlay 3R scope of work, and in the middle is a culvert replacement, a new and reconstructed type of work. This is generally acceptable. See page 40 of the Minimum Design Standards. It is not allowable to mix and match different standards within a work segment, or to apply urban standards on one side of the road and rural standards on the other side of the road. This is one of the series of videos on Nebraska's system of classifying and applying standards to its highways, roads, and streets. This video addressed design standards and requirements for resurfacing, restoration, and rehabilitation, commonly known as 3R.